All right, so I'm recording now, and 22nd year of CLAMP. I'll turn it over to Dennis. He's going to give us a fearless look
Yep.
at our data.
All right, thanks, Jane. I'll share my screen here then too, and then we can kind of talk about if there's any questions at the end, we'll discuss it. But let's see here.
It's a clamp, our first Halloween party. Oh.
Very clever.
There we, is that working for everybody?
That's good.
All right. And everybody can hear me just fine?
Yes.
Okay, let's see if I have to move my camera, how I can, so I can see. So it looks like I'm looking into the screen here, but.
It's got a PowerPoint up.
All right, so yeah, welcome everybody. I know this was kind of a different year for most people, for sure. But welcome to the Halloween. We're gonna be looking at some of what we found today, or found this year during CLAMP. Just thanks to the Iowa Lakeside Lab and the Friends of Lakeside, and all of you clampologists out there that are that helped us out this year. So as you can see, the CLAMP program, this isn't anything too new to any of you guys, but it's pronounced the Cooperative Lakes Area Monitoring Project. One of my favorite movies, Young Frankenstein here, but so we have 27 sites for CLAMP, and they are sampled 7 times a year, as you all know, and June through September, two times a month, and the 1 time in September. But you can see Silver Lake and Center Lake and East and West Okoboji, Big Spirit, Little Spirit, and the lower chain there, Upper Gar, Lake Minnewaska, Lower Gar. One thing that I wanted to point out this year too was that there's now a Gleon buoy on Big Spirit Lake. So we had one on West Lake since I think 2015, and this was the first year that we had one on Big Spirit. And it's kind of up in the, there's little waves up on the map there that kind of show where that's located, I think. And so it's kind of in that general area of the lake. And so both of those buoys collect water quality data like every 10 minutes. And so those buoys are gathering tons of data, and now we're going to be able to kind of use that as well along with CLAMP data to really look at these lakes in a really cool way, I think. So one of my favorite Halloween movies was the first Halloween. They kind of considered it a slasher movie, if you know what that is or not. But the CLAMP volunteers, they really help out. They cut the costs by quite a bit when for this monitoring. And so thank you guys so much for being able to go out there and collect these water samples and bring those back to the lab for us here for this program. One other thing I noticed was like the Halloween movie was, you might see a theme throughout this, you know, close to Halloween, I guess here, but Halloween movie was 91 minutes long, which when I kind of look through the data, it kind of looks like, you know, maybe not, I'm maybe making a stretch here, but a lot of what it takes for the volunteers to collect all the water samples per lake is about an hour and a half. So about the same length as the Halloween movie. That might be a stretch, like I said, but if we did use like an hour and a half for per lake, that would be over 1,617 hours that the volunteers have spent in 22 years of collecting clamp samples. So I think that's a real milestone to just say that's a lot of hours. So it's pretty awesome. So with all those hours of collecting, you know, if you go to our clamp blog, you can see graphs that are extending back to 1999 for Secchi disc readings on, you know, the lakes, various lakes. Here's one on East Okoboji, site 56. So there's a lot of information there, and you can really see over that period of time how things are starting to change. Also, you guys are collecting water temperature data and dissolved oxygen. You're filtering chlorophyll samples, and then we're running those analyses here in the lab and putting all of this information, and we're trying to keep it up to date as possible on that blog so everybody can see it and use that information like we were just talking about earlier with students and whatnot in schools and things of that nature. So thanks so much again for collecting all of these samples and measurements. So a little look into the highlights of the clamp year of 2020. Okay. Oh, what just is, oh boy.
It's a ghost.
Something crazy is happening with a pH probe, I guess. You know. So this year we did have a few record Secchi readings. I know Jane likes to say Secchi, and she's probably right in that. I don't know. I just say Secchi. But this year on Big Spirit Lake in June, they had a Secchi reading of 6.4 meters. The previous high that we had seen was like a 4.8 meters in June of 2015. So we definitely saw some pretty extreme water clarity in Big Spirit this year. And so I don't know if it's possible that it's if the zebra mussels are starting to show up a little bit there now that is causing that or what, but we'll see if that's going to be trending that way every spring from now on, or early summer. Also, Little Spirit Lake had some major water clarity at the beginning of the year too. So Steve, there's some of your information. Yeah, 2.85 meters, and then also, yeah, I guess you were sitting on the bottom at the south end of the lake there on that one sample at over 2 meters. So that's some of the best water clarity that Little Spirit has seen over the course of 22 years, for sure, at the beginning of the summer. And then also West Okoboji. This is not technically an overall record, but it was just for the early June sample, there had never been anything quite this high as 11.3 meters of Secchi depth in the month of June. So looking at all of the lakes, we're looking at median readings of this data. So it's a little different than the average reading. It's like the middle number in the range of measurements that were taken over the course of the summer. So it kind of throws out the highs and lows a little bit more of the measurements that we're taking, and gives you that kind of the middle reading for the summer. So you can see the lakes were all at or above what they typically have been over the course of the 22 years that we've been sampling these lakes. The yellow line there is what the 22-year median Secchi reading. And then also that kind of reddish line, if you can see that at the 1 meter area, that's where the DNR would like all the lakes to at least meet that 1 meter Secchi depth or better. And so there's Big Spirit, Minnewaska, Upper Gar, and West Okoboji that were exceeding that. And then the other lakes like Center Lake, East Okoboji, were near that. So, but they are all basically, like I said, at their median or surpassed it this year. Then this is a new thing this year, as everybody kind of knows, that we started to do pH measurements. So looking at pH, pH can stand for the power of hydrogen or the potential of hydrogen. I guess there's maybe a couple different things that what the pH stands for. So as it shows here, it's a measure on a logarithmic scale between 0 and 14, where pure or neutral water is at 7. And so that means the logarithmic scale basically means that if you go from, say, 7 to 6, that's 10 times more acidic than what 7 is. So if it drops, if the pH would be 6, that would be 10 times more acidic than what the water at 7 would be. And the same goes the other direction. If it was at 7 and then you measured a pH of 8, that would be 10 times more basic or alkaline. So as it says here, we started thinking that the pH would be a good test to start doing out in the lakes, just because it tells us a lot about the environment and how it can affect the aquatic life. And it's also indicator, or also plays a role in like looking at how different chemicals or metals or things like that could change in the water due to the pH levels. And so a lot of the times, and also just like the aquatic life, we can look at when we're measuring the pH, we're seeing if it's going to be suitable for aquatic organisms. So, so there's a variety of things that can play a role in pH in the water. One of the processes is like runoff, and there's a lot of carbonate and different things like that that are in the soils in Iowa. And so that can be, when the water's flowing through that the water is picking up some of this carbonate and bringing it into the water. Also, precipitation and wastewater interactions with the lake, and then also carbon dioxide. So these are all important processes that we need to look at and what might be affecting the pH. One thing in particular too is like the photosynthesis of algae and how they use hydrogen during this photosynthesis process. And then when those algae are dying or decomposing, that can also affect the pH of the water. So that's a couple reasons why it's important to be looking at that pH level. So here was an example of when we were taking some pH readings on Big Spirit Lake, and then also looking at what the pH level was on the Gleon buoy on Big Spirit Lake. And so the cats are the pH level that the volunteers took measurements for. They took one on the early June, and then July 7th, August 6th, and August 25th. And then we have the pumpkins that are the Gleon buoy measurements. And so you can see some of them are pretty close for Big Spirit. The one July 7th was off by about, I think, 0.7 for the pH, but the others were within basically 0.2 of each other. So that's actually pretty good. I would say if we can be within a difference of 0.2 for the pH, you know, from the Gleon buoy, or from when we, when we maybe do some more work this winter to make sure that these probes are working properly. If you can be within plus or minus 0.2 of a true value for pH, I think that's a pretty good thing. Then I also looked at, we looked at West Okoboji pH readings and compared the pH results with the Gleon buoy. You can see on West Okoboji there was definitely a little more variability or difference between the Gleon buoy and what the pH probes were reading. So anywhere from like -3 difference between the buoy and the pH probe, and then up to 0.4. Most of the time it was about 0.4 pH units different. So that, for whatever reason, was not quite as close as what we would like to see. So again, we're going to try to do some more experimenting this winter just to see if there's something else that we need to be doing with these pH probes to make sure that they're working properly, and then getting that information out to the volunteers when we use them. And so here's the median levels for the pH readings for all the lakes this year. And so you can see it ranged from like 8.7 on Lower Gar Lake to 9.25, a little over 9.2 on Center Lake. And most of the time, so where the point is at the top of the cat's tail, so if you didn't know. But as you can see, most of the pH readings were fairly high, I would say. I mean, higher than what I would have expected. I mean, 9 would be the max of what I would think we would see most of the time. But most of them here, yeah, we're running close to 9 or a little over, except for like Big Spirit and Lower Gar and West Okoboji. So again, more investigating over the winter here on these and seeing if this is something that is really actually happening out there, or if it's something that the probes are a little, that we have to deal with the probes. But also still very interesting. Then we're going to talk about some record low TP readings, or total phosphorus. So this year we saw some record low phosphorus levels in Center Lake. So it was pretty cool to see like that was occurring out there. And so I think there was a little bit of a trend this year too, where we were seeing also some tied for record lows for East Okoboji and Lake Minnewaska and Upper Gar. So I think potentially with the lower water levels and less runoff, we were probably seeing some of that happening, but also it could be just trending that way for some of these lakes as well. Honorable mention goes to Little Spirit Lake too, because there was actually the lowest phosphorus levels that we were seeing there in the past 7 years. So that was also a good thing to see. So again, looking at these median phosphorus levels, again, you can see the yellow dashes, that's the 22-year median total phosphorus readings. And you can see basically all the lakes were pretty good, well below what the median levels that they've been having. So we were definitely seeing some pretty low phosphorus readings this year. the DNR standard, or what they are showing as what they would like to keep phosphorus levels below, are 35 micrograms per liter. That's what this this scale is on this graph. So, which is not being met, but I think that even if where a lot of these lakes are at, if they're like around 50 or less, I think you would see dramatic changes in some of the algae growth in some of these lakes if it would be consistently 50 or just slightly under 50. But and then finally, we're going to look a little bit at what's called the Trophic State Index. And so this is like I've probably talked with people, maybe know some of this already, but this is the classification system basically designed to kind of show how much biological productivity there is in a body of water. So we're looking at, yeah, the living biomass or biological material in the water. And so the three things that we're looking at are the chlorophyll pigments, which are indicator of algae, and then the water clarity, so the Secchi depth, and then the phosphorus readings. And so when we look at these, that they all can help in estimating the biomass of the algae in the lakes. So this kind of just shows exactly how these three parameters that we test for kind of have a relationship. So as you can see, like if you had, say, a 1 meter of water clarity, which is what the DNR would like us to have, if you measured that in the lake and then we took a water sample, a lot of what this says is that when we analyze that water sample, that we should get a phosphorus reading of about 48 micrograms per liter or 50 micrograms per liter. And then if we also analyze that sample for chlorophyll, we would get 20 micrograms per liter of chlorophyll. So then what we do, since those three numbers like Secchi and phosphorus and chlorophyll aren't really as that comparable necessarily, what we can do with the Trophic State Index is actually we put those numbers into some formulas, mathematical formulas that convert them into numbers that are in a score of 0 to 100. And then they are more comparable because then you can look at them on a scale of 0, all of them on a scale of 0 to 100. And so in this case, those three numbers would be able to be converted basically into a score of 60. So when those numbers, or when the trophic scores are very similar to each other, then that is a strong indication that all of those three parameters are fairly correlated pretty well to each other. So here's an example on East Okoboji Lake. This is from all of the trophic index scores from 1999 to 2020. And so when you see the algae abundance, the water clarity, and the nutrients, so all of those symbols, when you see those all tightly together each year, that's a strong correlation that if there's certain amount of phosphorus, that phosphorus is creating a certain amount of algae, and then that amount of algae is giving you a certain amount of water clarity. So it appears that on East Okoboji, especially since 2010, you're seeing a pretty strong correlation between those three parameters, and you're kind of starting to see, I think, definitely an improvement in all of those things, especially since 2010. 99. But for sure, since 2010, there's been a fairly tight correlation on that. And then also looking at Center Lake, we're seeing a pretty stable lake, I would say, as of since 2013. It kind of has been staying right around the same trophic state. I just find it interesting. I think it was 2010 when they maybe changed the water levels there or dropped the water levels. And then it looks like for a couple of years, things were kind of bouncing around a little bit in 11 and 12. But then since 2013, things seem to be a little more stabilized in that trophic state. So this is just a quick look then at all of the lakes and their trophic states for the various parameters for 2020. And the DNR would like to see lakes land below 65 for the trophic state index score. If they're above or slightly above for a long period of time, then they would want to start looking at, what could be done in those lakes to maybe see what the problem is. Why is it staying up, above 65 for a long period of time? Is it something with phosphorus within the system, or too much algae, or wastewater discharge or something like that, or or septic systems or something like that. But so you can see in 2020 here, most of the lakes were right at or below that 65 index score, and they were all pretty well correlated with looking at these three parameters and how they're showing what the trophic state or the status of these lakes are in right now. And with that, I just again want to thank all of you for your help during 2020. So I guess the Wicked Witch had a little advice for us, and so I guess with that we can if you have any questions, you can let me know.
Thanks, Dennis. I'm going to stop recording just in case